today we are working on the 6-4 lesson, which is dividing a polynomial by a monomial. So that's why we started with a warm-up on the quotient rule. All right, so I know it's been maybe a week or so since we've gone over the exponent rules and practiced them. And that includes the quotient rule. So we have learned this before, just trying to see what you retained. Make sure that your notes are up to par, so that way you can use them on your test, which is coming up on Tuesday. We'll go over some from the warm-up in a second, the ones that were most commonly missed. But even if you are absent, you are held accountable for anything that we do, including this warm-up. So, I mean, you all are here. You should have been able to get it done. But just know if you're ever absent, always look at the slides for anything that we did that day. Then here's how you will be graded on this lesson. So on the test, you need to be able to break up the problem into smaller fractions. You need to be able to divide each numerator by the denominator, which means coefficients you treat like normal. If it's 10 over 2, you still do 10 divided by 2. But you need to use the quotient rule when you're dividing variables of the same base. So hopefully you remember the quotient rule. That one says that if you have variables of the same base being divided, you subtract the exponents. So we'll do a few of those to kind of warm ourselves up for the class. I'm recording now and I'll link it in the slides after we're done. But do check out the other videos if you're ever lost at home. Is mostly what those are for. Because when you're here, you should be asking me questions if you're ever confused. All right. The practice you guys picked up on your way in. So the practice is evens or odds. All right, so sorry, as I was saying, the practice is just evens or odds. My first hour had like 20 solid minutes to work on it. So what the plan is that you'll have the rest of today to practice. Whatever you don't finish will be homework. And you need to have it done by the time you walk into class tomorrow. Because when you walk into class tomorrow, we're going to do an entrance ticket on this lesson. And I'll check that practice during the entrance ticket. So really today's lesson does not take very long. So that's why I'm just going to keep moving along with the schedule. One thing I do want to make you guys aware of, I'm not sure if you realize this, but everything, like if you're looking for the most up-to-date stuff for my class, is always in Schoology. So if you check the grades tab in Schoology, and you can even do that while I'm talking, you'll see assignments if they're flagged as missing. You can click on the link that's right here. And this is from last year, so they're different titles. But you just click on the link and it takes you directly to that assignment where you can upload it. It can show you what the assignment looks like because I always upload the file for whatever assignment it is. So if that applies to you, that might be easier for you to turn your stuff in. And then occasionally we have like some online assignments like the green puzzle pieces. You can complete those directly from clicking these links. So that's just like another cool thing I wasn't sure if you were aware of. Since the deadlines are coming up, make sure that you are getting your missing work turned in. So again, we're taking an entrance ticket tomorrow because this is a short and sweet lesson today. So if you're struggling through it today, you need to ask. Questions? All right, so then on to the note sheet. You should have this one in front of you. If for some reason you don't and you looked in your backpack like 2 times, then ask me for one. But it was given out yesterday, so you should have it. And for this lesson, dividing a polynomial by a monomial, you need to know the quotient rule. So actually, let me go back to our warm-up for a second. Let's do ones together that were most commonly missed. So like this one was one of them, the second one. What does the quotient rule say to do? To subtract the exponent. So if I have x to the a over x to the b, that's equal to x to the a minus b. So that's what I'm doing here. I have x to the fourth over x to the first, because what's the exponent if it's not written? So x will be to what power? First. So x to the first, or sorry, x to the fourth over x to the first gives me x to the fifth. Good. And same process with the y's. So stuff that has the same base, you subtract the exponents. Y to the ninth over y to the sixth gives me y to the, what's 9 minus 6? So that is why this option was the one you should have picked. And it might be in a different order on your screen, but x cubed, y cubed. Good there? All right, another one that was most commonly missed was the second to last one. So let's look at that one. All right, and it's just one that has a negative exponent. So that's when you have to use your negative exponent rule. What does the negative exponent rule say? What was the right answer to this one? So this one, right? So it says that if I have x to the negative n, that's equal to 1 over x to the positive n. Same where if it was negative in my denominator, 1 over x to the negative n gives me x to the positive n. So essentially, anytime you have a negative exponent, like you did in this one, even if it's not written as a fraction, you can write it as a fraction. Because all whole numbers are over what? 1. So if you have a negative exponent, you're only moving the base with the negative exponent. So x cubed will move to the denominator. If there's nothing left on one side of the fraction, put a 1 as a placeholder. But that x cubed gets rewritten as positive once it's moved over the fraction mark. So that's another rule that you do need to know because it's not proper to have negative exponents in your answer. So questions on this one? All right then. So let's look at the notes. Let's fill in the quotient rule, which we just went over in the warm-up. X to the a over x to the b equals x to the a minus b. And there's two methods you can use when you're dividing a polynomial by a monomial. It's just your preference, whatever gets you the right answer 100% of the time. I'll show you the first method in example 1. So that one says to break up this fraction into smaller fractions. So it'll always be multiple terms divided by one term at this level. You'll see it more complicated in like algebra 3-4, but in this class, we're just going to be dividing by a one-term expression. So if I were to have a fraction, like maybe 2 plus 3 over 5 written like that, what's 2 plus 3? I get 5 over 5, which really equals 1. So this written like that would be the same as if I split it up. If it was 2/5 plus 3/5. Because they have the same denominator. What's 2 plus 3? And then according to the rules, the denominator stays the same. So I get the same thing, whether it's written like this or like this. So the same logic applies for these. I can break this up into smaller fractions. So each term can be written over what the denominator is. So like 8n squared over 4n. And then the next term is negative 36n over 4n. Yes? When someone comes back. All right, so this is the equivalent of writing it smushed together. Everyone with me so far? And then writing it like this ensures that we're dividing each numerator by the denominator. Coefficients, the numbers in front, you treat normally. What's 8 divided by 4? Good. And then the variables of the same base, you use that quotient rule. So what's n squared divided by n? N, good. And then once you've divided that out, move on to the next term. So start with the coefficients. What's negative 36 divided by 4? Negative 9 is correct. And what's n to the first divided by n to the first? N to the 0, which equals 1, right? So if you have the same thing on the top and on the bottom of the fraction, they cancel out. So I'm not going to have an n next to the 9. I'm not going to put n to the 0 because that's not really simplified, right? Negative 9 times 1 would just be negative 9. So now that I've divided that out, and I'll move it over here so that you can see like what we did, we're finished. Right, as long as it's in standard form, then you're done. That's one way. Questions on that way? All right, so now I'll show you a different way in example 2. And it's not like a method I've ever seen in like textbooks or anything, but I call it the highlighter method. So this just kind of doesn't make me break it up and write it into smaller fractions, but it ensures that I divide each term in the numerator by the denominator. So we're going to work this out first. What's negative 14 divided by 7? Negative 2. What's x to the 12th over x squared? Use your quotient rule. 12 minus 2 is. And then y to the 5th over y squared gives me y cubed. 5 minus 2 is 3. So we divided out the first term by the denominator. Questions on that part? All right, and then in a different color, I'll highlight what I'm dividing next. Now it's what's in the green. It's the second term divided by the denominator. Now I'm sure you can probably just do that in your head, but this kind of just keeps it organized and you can see what's going on. So I have a positive 7 divided by 7. What do I get? One, and it's positive, so put plus 1. X squared over x squared gives me 1. Basically, it cancels out. And then y squared over y squared gives me, it cancels out again to 1, which I mean, I wouldn't write 1 times 1 times 1 here. What's 1 times 1 times 1? 1. All right, so then check the answer. Is it in standard form? So then we are finished. Questions about that? All right, I'm going to give you a couple to try. Josh, you can go now. So I'm going to give you number 2 to try, number 3, and another one, number 6. So try 2, 3, and 6 for right now. And I also want to add that the level of difficulty of these problems on this first page matches the level of difficulty on the test. All right, we'll still do a couple on the back page so that you can see like the negative exponent rule, but if the front page makes sense to you, then great. All right, but number 2, did you guys break it into smaller fractions, or did you just use the highlighter method, or make sure that you divided each one by the denominator? What did you do? All right, I think that one is easier to follow. Just make sure that you divide each numerator by the denominator, so each term. So what's 10 divided by 5? And then b squared over no other variable. What does that give me? B squared. That's like having b squared over 1. And then the next one. 5b over 5. What's 5 divided by 5? And it's positive, so I'll put +1. And then b over 1 just gives me b. Last term to divide out is the -15 over 5. What does that give me? -3. So I guess the key thing there is just making sure that you keep the sign that's in front of each term. Check the answer. Is it written in standard form? Yes, so we can box it up and be done. And no, you do not need to write the 1 in front of the b, but I won't like donkey points if you write the 1. So questions on number 2. All right, so then let's look at number 3. I have 8a cubed divided by a. So if there's no coefficient, what's the coefficient? 1. So 8 divided by 1 is a cubed divided by a is a squared. Next term, I have -a squared divided by a. What does that give me? Or sorry, I meant to say -2a squared divided by a. What does that give me? Good. And then the last term to divide out, 5a over a gives me 5. Check the answer. Is it written in standard form? So then we are finished with number 3. Questions so far? All right, so number 6, something with more variables involved. Again, just take it one term at a time. So this first term divided by the denominator, what's 6 divided by -2? And a squared divided by a. B divided by b, it cancels out. So I don't need to write b on this one. So then we're on to the next term. So I have -12ab squared over -2ab. What's -12 divided by -2? Good, so make sure that you put +6. A divided by a cancels out. B squared divided by b. Good. Questions at all? All right, so if you thought those were pretty easy, then I'm confident you'll get them right on your test. Let's look at the back side. We'll do number 13 together, and then I'll have you try 14, but I just want to make it clear, you won't have something necessarily this hard on your test as far as dividing goes. All right, but these two examples, you get to see the negative exponent rule. So rewrite the negative exponent rule here if you didn't before. If I have x to the negative n, that's equal to what? Good. And then if it were in the denominator, like 1 over x to the negative n, how would I rewrite that? Good. So you'll see in number 13, we get negative exponents. We'll rewrite them using this rule. But just take it one step at a time. So I have negative 24 x to the 7 over 3x to the 5th. What's negative 24 divided by 3? Negative 8. X to the 7th over x to the 5th gives me 7 minus 5 is 2. Good. Next term, I have 9x cubed over 3x to the 5th. What's 9 divided by 3? And it's positive, so put plus 3. And then x cubed over x to the 5th. What does that give me? X to the negative 2. Now, don't move negative exponents until the very end. All right? But no matter like how ugly it may be, it's always the top exponent minus the bottom. So 3 minus 5 gives me negative 2. Questions about that? All right, so then we'll divide out the last term. What is negative 15 divided by 3? And it's negative, so make sure you put minus 5. And x to the 1st over x to the 5th gives me x to the negative 4. Now, if this happens to you, I always want you to imagine that it is over a fraction bar, even if it's not set up as a fraction already. So our answer is not set up as a fraction. I can't put a fraction bar over the whole thing because that wouldn't really be proper, because we're not going to divide the whole thing by x squared or something like that. So just on the terms that have the negative exponents involved, make a fraction bar. So it's going to be under the 3x to the negative 2 and what else? The negative 5x to the negative 4. This one can stay how it is. Now, according to the rule, only the bases with the negative exponent need to move. So since 3 doesn't have a negative exponent, that's 3 to the 1st power. I'm not going to move the 3, just the x to the negative 2. What else needs to move? The x to the negative 4. So not the negative 5, because negative 5 has a positive exponent. It's negative 5 to the 1st power. Just these ones need to move. And then I do want to like clean up my answer. I don't really have anywhere to write it, so I'll write it over here. So my final answer will look like this. Negative 8x squared plus 3 over x squared minus 5 over x to the 4th. So any questions on 13? All right, again, I won't give you something necessarily like that on your test. If you can do the whole first page, I'll be happy. But I will have you try 14. We'll project the answer. and then you'll have the rest of the time to practice. So try 14, it'll be like 1 minute. All right, but 14 was the one that I had you try. So initially, you should have had this first line. So again, each numerator has to be divided by the denominator. So each term by the denominator. 15 divided by 5 is 3. X to the 5th over x to the 4th gives me x to the 1st. And then you move on to the next one. Negative 25 divided by 5 is negative 5. X cubed over x to the 4th gives me x to the negative 1. 3 minus 4 is negative 1. Last term, so 5 divided by 5 is a positive 1. They chose not to write the 1, so that's fine. And then x squared over x to the 4th gives me x to the negative 2. Only the terms with the negative exponents need to move, and they'll be over their own like individual fraction bar. So the x to the negative 1 will move to the denominator, x to the positive 1. And then this one moves to the denominator. If there's nothing there, you don't want to put like 0 or something, put 1 as a placeholder. So questions on 14. If you got that right on your first try, good job. But again, like I said, the level of difficulty is more like what's on the first page. So I just want to kind of remind you, if it completely cancels out, you still need to have 1 as a placeholder, like in situations like this, like negative 5 ABC over 5 ABC, minus 1 in your answer. Or situations like in example 2 that we saw. This is the same as this, it cancels out to 1. They still have to write the 1, you don't want to put plus 0 if there's nothing else there. So any questions? All right, you have the rest of the time to practice. If you have questions, please ask.